Good morning. We are group 28 and this is our BrainNet project. So we come to our login screen, which is our initial screen, the app, and as you can see there's username, EDF file, classifier and server. We try to log in with this. Oh, I forgot the EDF file. So trying to select 9. So you can see we selected number 9, and then if we try to run it, you can see that the authentication has failed in the pop-up screen because the user is at user, and for this particular phone we have had the information only for S01, which is our user. So we try to change that as our input, and as the username, and you can see it's collects classifier as naive Bayes and the cloud server. So we try to run that, for which we can see there's an authentication has been successful. The latency is now at 276. So trains the server to a fog server and try to run the same thing with S01. See that the latency is at 45, which is much lesser than what was the latency at the cloud server. So this is what we basically did, and there are different classifiers for which we have designed this: SVM, KNN, and decision tree. And the EDF file is all selected. Thank you. Since we have completed 80% of our project, we still have to figure out the power consumption and also the best offloading tactic which would be suitable for our project. And thank you.
We have set up the cloud server in AWS for our BrainNet project. I'll give you a quick walkthrough on the code that we've used to set up the cloud server. So we have used the Spring framework in order to handle HTTP requests. So this is the Spring framework. So if you do authorize user and give the EDF file, we will be able to test the EDF file and authorize the user. We have stored our EDF files in Amazon's S3 bucket. So we will be fetching the EDF file from the S3 bucket, which has been transferred into the S3 bucket using the Android code. So this is the code for handling the S3 bucket and downloading the object. So model driver is basically the one that drives the model. So we will be executing the model.sh with its EDF file, and that will provide the result, which we will be sending as a response to the HTTP request. So this is basically the code that we have used. So we have set up EC2 instance. This is our EC2 instance, which is running, and it is running in this IP address 54, 183, 130, and 229. So we have used SSH to log in into this. We have used SSH to log in into this instance, and so I've copied all the files now. We can see that there's no EDF file right now, but once we execute it, we'll be able to see the EDF file that has been downloaded from the S3 bucket, which I'll be showing you in a short while. So my code is running, so it should handle the HTTP requests now. So this is the cloud server, so I'm running it in my EC2 instance. You can see it here. So let's see if our EC2 instance is working. So it's just an info. So the info will print in a message called the service sub, which is basically here. and then we will now run with the EDF file. So this EDF file is present in the bucket. So this is the name of the EDF file. So we can copy this and we can put this. This EDF file will basically be uploaded by the Android code. So this will run. So while this runs, we can see that this is the code that we have used to run. So this now runs a naive-Bayes model. We'll be using more than one model in our program, which will be used to test it. And then you can see that this is being the EDF file is being saved in home EC2 user and the file name. So once this authenticates, you'd be displayed which user that's been authenticated depending upon what is the value. Right now we can just and now we can see that the EDF file is being saved. So we have downloaded the EDF file and we have run the method execute model.sh. So this execute model.sh will basically has the code which will run along with the name of the EDF file. Here in our local system, which is basically what will be happening in the Fog server. So we will be running this code, and then you can see that it is actually running the model and creating the model using naive Bayes.